Hi, class 12. Good morning. Today we are going to discuss about method of substitution. We're in indefinite integration actually, but the method will be something different. It is known as, this process is known as method of substitution. Method of substitution. Basically, what is all about? This is something, let us consider an example first, that is x into e to power x squared dx. Here, this is not in a standard integral form. We know that, we all know that basically e power x dx, that is equals to e power x plus c, where c is the integral constant. We all know that. We all know that. But this is not in actually in standard form, standard integral form. So we need to convert this one into a standard format. So what will be the basic procedure? What will be the right or correct procedure? For that, we need to put something like x squared equals to t. That is, we are substituting x squared by t. So what will be the basic procedure? X squared equals to t. After considering x squared equals to t, we need to differentiate it, both sides. If we differentiate x squared, we will get, with respect to x obviously, that will be 2x. We all know that. And differentiation of t, that will be dt by dx. We are differentiating both sides with respect to x actually. So what will be the procedure? If 2x equal to dt dx, then 2x into dx, that will be dt. 2x dx, that will be dt. Hence, x into dx, that will be half into dt. Half into dt. So, in this form, if we consider x into dx, this one, x into dx, this one, by half into dt. If we replace x into dx by half into dt, then what will be the result? That will be half into e power. We considered actually x square equal to t. So that will be e power t into dt. Now, half will come out and that will be in a standard, that will convert into a standard integral form. And we all know that e to the power t, integration of e to the power t, that will be e to the power t plus c. Now we need to put t equals to x square here once again. So that will be half into e to the power x square plus c, where c is the integral constant. C is the integration constant. So that is actually the method of substitution. That is actually the method of substitution. So method of substitution actually converts an integral into a standard form, so that we can apply the basic standard integral formulas, something like e power x dx, or something like 1 by x dx, integration of 1 by x dx, that is log mod x plus c. That's the basic procedure. We will consider another example. Say it has been given that e power, integration of cos log x by x dx. That is the given integral. Now, if we look at it, it has been given that here here is a log x. Okay. So log x, if we substitute log x by something, log x equals to t, if we put log x equals to t, we all know that derivative of log x is 1 by x equals to derivative of t, that is dt dx with respect to x actually. So 1 by x dx, that will be dt. Now the dx by x part, clearly that will be dt. Excuse me. So that will be integration cos of log x. Log x, the value of log x is t, we have considered it, and dx by x, clearly that will be dt. Now we all know that the integration of cos t dt integration of cos t dt, that is sin t plus c. Now we consider that t equals to log x, so that will be sin log x plus c, where c is the integral constant or integration constant. So we are substituting a variable here whose derivative is also present in this particular integral, and that's the method of substitution basically. And we need to consider this thing very carefully. Now we are going to discuss about another example. If we consider this example, integration, the previous one was x e to the power x square. Second one is cos log x by x dx. Now we are considering log x by x, just log x by x. Very easy integration. We all know that log x, whose derivative is 1 by x. We all know that. And look at it, 1 by x is also present here. So we need to substitute log x by t. So log x and its derivative will be 1 by x, that will be dt by dx. Hence, dx by x, that will be dt. So that will be log x is equals to t. So we put t here, dx by x equal to dt. So that will be dt here, and we all know that it is in standard form, and integration of t dt, that will be t square by 2 plus c. And value of t, we all know that it has been considered log x as log x. So log x whole square divided by 2 plus c, where c is the integral constant or constant of integration. So these are the basic problems. Now we are considering this one, this type of problem. Number 4, integration root under 2x minus 5 dx. What will be the procedure here? The procedure will be, here we need to consider 2x minus 5, that is equals to t square. Why? Because if we consider 2x minus 5 equal to t square, so under root 2x minus 5 will become just t, right now. And what will be the differentiation value here? We know that 2 will come out. Differentiation of x is only 1. Differentiation of 5, that is 0. And differentiation of t square, that is 2t into dt by dx. Hence, 2 into dx, that will be 2t into dt. And 2 cancels each other, so we get that dx equals to t into dt. Now, if we substitute those values, that will be root under 2x minus 5, that will be root under t square, and dx equal to t into dt. Under root t square will be t and into t dt. Actually this will be modulus t dt, modulus t into t dt, because we all know that root under t square, that can be also plus t or it can be also minus t. So we need to consider both modulus t into t dt, and this is actually plus minus cases. That will be t into plus minus. If we remove modulus sign, a plus minus will come out and the whole expression becomes t into t dt, and that is plus minus integration t square dt. And integration of t square, we all know that is t cube by 3 plus c. Now the value of t, clearly we can say that value of t is under root 2x minus 5. Here a cube is given, so root under 2x minus 5 whole cube, total by 3 plus c. So that's our basic answer. That's our actual procedure. So we're considering another example. Say integration e power minus 1 by x into 1 by x square dx. So what will be the procedure here? If we consider e power minus x as t, then what will be the derivative? The derivative value will be, we all know that the derivative of e power x is something like e power x, yes or no? Are bhai, e power x is such a function whose derivative value is also e power x, whose integral value is also same, e power x. So actually that will be e power minus 1 by x. According to the rule, that will be e power minus 1 by x. Now we all know about chain rule. The chain rule indicates that we need to differentiate minus 1 by x also. And this is equals to dt by dx. Now e power minus 1 by x, ddx of minus 1 by x, minus will come out. 1 by x, differentiation of 1 by x, that will be minus of 1 by x square, that is equals to dt by dx. We all know that 1 by x whose differentiation is 1 minus 1 by x square. We all know about that. Actually we have studied it in first order derivative. So that will be minus minus plus e power minus 1 by x into 1 by x square dx equals to dt. We need to substitute this value. Look at it. E power minus 1 by x is 1 by minus 1 by x into 1 by x square. I've just considered e power minus 1 by x equals to t, and look what happened. Look what happened. We get that e power minus 1 by x into 1 by x square dx total equals to dt. And it is the total expression here also. So we need to substitute this one by dt. Very simple theory. And the total integration value will be t plus c, where c is a integral constant, a constant of integration, constant of integration. And the value of t, we need to put that value. So value of t is e power minus 1 by x plus c. That's it. हो गया, ये प्रॉब्लम सॉल्व हो गया. तो उसके बाद the next one is, that's our fifth problem actually. That was our fifth problem, and we are going to discuss about number 6. The number 6 is something like, let the given integral is cube root of 3x plus 5 dx. Very similar to this one actually, very similar to this one, number 4. Here we have considered that 2x minus 5 equal to t square because there was a square root. Now in this problem, it is cube root. It is cube root actually. So we need to consider 3x plus 5, that is equals to t cube. As per the root is given here, we need to consider this one. If a fourth root is given here, so we need to consider that is equals to t power 4. If a fifth root is given here, we need to consider this one equals to t power 5. Very simple procedure, very simple. So here cube root is given, so we need to consider 3x plus 5 equal to t cube. Very easy calculation. So after that we need to differentiate it, and after the differentiation procedure, that will be 3. Differentiation of x, that will be 1. Differentiation of 5, that will be 0. 3 into dx. Differentiation of t cube, that will be 3t square into dt. So after cancelling 3, we get dx equals to t square into dt, right? Dx equal to t square into dt. Now we are substituting this value. So what will be the result? That will be cube root of t cube into dx t square into dt. Now cube root of t cube indicates that will be t into t square into dt, and t into t square, that will be t cube dt, right? So t cube integration t cube, actually t power 4 divided by 4 plus c, and the value of t is something like cube root of 3x plus 5 whole power 4 divided by 4 plus c, where c is the constant of integration. Constant of integration. Constant of integration. Now, we need to consider the formulas of this chapter. Consider about the formulas of this chapter. The formulas are something like this. Formulas are integration of tan x dx. That is, two formulas are there. First one is negative log mod of cos x plus c, and the second one is log mod of sec x plus c. Log mod of sec x plus c. So what will be the procedure here? Actually, it can be given as a problem also. We need to know about that thing also. So in order to obtain the integration value of tan x, we need to break tan x as sin x by cos x. After that, we need to consider cos x equals to z. We all know that the derivative of cos x is minus of sin x. We all know that, and that is dz by dx. You may consider this one equals to t also. So sin x into dx, sin x dx, that will be minus of dz. So sin x dx equals to minus of dz divided by cos x. Cos x, the value of cos x is z, so that will be minus of log mod z plus c, and we all know that z is cos x here, so that will be minus of log mod cos x plus c. So that was the first formula. And what will be the second formula? The second formula is very easy. Just consider minus log mod cos x as log mod cos x power minus 1, and that will be log mod sec x. You all know about that the cos x, reciprocal of cos x, will always be sec x. So that was our first formula. That was our first formula, and the second formula will be integration of cot x. Cot x dx, integration of cot x dx, that will be log mod sin x plus c. Why that will be log mod sin x plus c? Because in integration cot x dx, we need to break cot x as cos x by sin x. We need to break it as cos x by sin x. After that, we need to put sin x equals to t. And if we consider sin x equals to t, the derivative value of sin x will be cos x, and differentiation of t will be dt by dx. So cos x dx, clearly that will be dt. So cos x dx is represented by dt here. So that is dt, our dt, and sin x is equals to t. So dt by t, integration of dt by t, that will be log modulus t. Log modulus t plus c. Now c is the basically constant of integration. C is the basically constant of integration. Constant of integration. Now the value of t is clearly known as sin x here. So the formula will be log mod sin x plus c. That's our second formula. Now we need to know about the third formula. The third formula is integration sec x. Integration sec x dx. So what will be the procedure, actual procedure here? We need to multiply, look at it, sec x in denominator, that is 1 actually. So we need to multiply sec x or the given function by sec x plus tan x. Simply by sec x plus tan x. Rest will be history. Just look at it. Sec x plus tan x dx. We just need to consider the denominator part as t. Sec x plus tan x equals to t. Now the differentiation value will be sec x, differentiation of sec x, that will be sec x tan x, and differentiation of tan x, that is sec square x dx, equals to dt. So after this step, we need to take common sec x, and the given expression will be tan x plus sec x dx equals to dt. So look at this one. That's our obtained result here also. So this is substituted by dt, and the denominator part will be transferred or substituted by t. So integral value of dt by t, 1 by t integration 1 by t dt, we all know about that. This is a standard integral, and the formula of this particular integral is log mod t plus c, where t is equal to sec x plus tan x, sec x plus tan x plus c. We are considering the base of logarithm here e also, so we are writing ln. You may write log also, log, no problem about that, but you need to mention about the base here, log e base, you need to mention about it. So that's our another formula, say integration of sec x dx, that will be log mod sec x plus tan x. Now it can be written as log mod tan pi by 4 plus x by 2 also. Why? That's our alternative formula. It's our first formula and it's our second formula. Those are most effective formula. Both are useful. How we can obtain this result? Look at it. Sec x plus tan x, that's a very easy problem of class 11. Sec x plus tan x, you may write it as cos 1 by cos x plus sin x by cos x. Sin x by cos x, and after that will be 1 plus sin x divided by cos x. And you all know that 1 may be written as cos square x by 2 plus sin square x by 2 plus sin x may be written as 2 sin x by 2 cos of x by 2, and cos x we may write it as cos square x by 2 minus sin square x by 2. So the total value will be cos x by 2 plus sin x by 2 whole square divided by cos of x by 2 plus sin x by 2 into cos of x by 2 minus sin of x by 2. So after that you may cancel one thing here. You may cancel cos x plus sin x by 2, cos x by 2 plus sin x by 2, and the rest part will be cos x by 2 plus sin x by 2, cos x by 2 plus sin x by 2 divided by cos x by 2 minus sin x by 2. After dividing it, numerator and denominator, by cos x by 2, we will get 1 plus tan x by 2, total divided by 1 minus tan x by 2. And you may write 1 as tan pi by 4, tan pi by 4 plus tan x by 2, total by 1 minus tan pi by 4 into tan x by 2, and you may write it as tan pi by 4 plus x by 2, because it's the formula of tan a plus b. Tan a plus tan b divided by 1 minus tan a into tan b. So that's our actual derivation. So you may write integration of sec x dx, that is equals to log mod sec x plus tan x plus c. You may use this formula also, and you may also that formula also, log mod tan pi by 4 plus x by 2 plus c. Now what about the next formula? The fourth formula is something like integration of cosec x dx. Cosec x dx, the same procedure, exactly the same procedure. We need to multiply it by cosec x minus cot x, cosec x minus cot x, total by cosec x minus cot x, and after multiplying it by cosec x minus cot x, we need to consider cosec x minus cot x as t. Cosec x minus cot x equals to t. So integration, so the derivative value of cosec x will be minus of cosec x into cot x, minus of cosec x into cot x, and the derivative value of cot x will be minus of cosec square x, and hence it will be plus of cosec square x dx equals to dt. Now we need to consider, we need to take cosec x as common. So the result will be in cosec x minus cot x dx equals to dt. So that's our whole expression here. Cosec x into cosec x minus cot x dx equals to dt. So you may write dt divided by t. So the result, you all know that will be log mod t plus c, where c is the integral constant. Now log mod t, we know about that, t equals to cosec x plus cot x. So that will be cosec x plus cot x here, cosec x plus cot x plus c, log mod cosec x plus cot x plus c. That's our first formula. Cosec x minus cot x, actually, I'm sorry, cosec x minus cot x. That's our actual formula. Now you may write it as log mod something like, look at the derivation. Cosec x minus cot x may be written as, cosec x minus cot x may be written as 1 by sin x minus cos x by sin x. Now that will be 1 minus cos x divided by sin x. You all know that 1 minus cos x is 2 sin square x by 2 and sin x is 2 sin x by 2 into cos of x by 2. Now the sin x by 2 part will cancel each other and 2 also cancel. So sin x by 2 by cos x by 2, that will be tan of x by 2. So ultimately what will be the formula here? That will be log mod tan x by 2 plus c. So our alternative formula is log mod tan x by 2 plus c. So integration of cosec x, first formula is log mod cosec x minus cot x, and the second formula is log mod tan x by 2 plus c. You need to apply these two formula actually in various problems. Now a special type of form, the last form of our preliminary discussion, that's something like e power x into fx plus f dash x pattern. Now what is it all about? It is about, if you consider it by this example, you will get something like this, e to the power x plus into sin x plus cos x. That is, we are considering fx as sin x and the derivative of fx will be also present there. As we all know that derivative of sin x is cos x. So this type of problem is known as e power x into fx plus f dash x pattern problem. And what will be the procedure here? The procedure is very easy. You just need to consider e power x into fx as z. E power x into fx as z, and total derivative will be e power x into f dash x plus fx fixed e power x. Derivative of e power x is e power x as we told earlier. So into dx, that will be dz. So if we take e power x common, we will get fx after rearranging fx plus f dash x dx. This is equal to dz. So this is our e power x into fx plus f dash x part. Now look at it. This is the whole integral here, and we are getting that integration, substituting total as dz. Integration dz is z plus c, and the value of z was e power x into fx plus c. So by this format, you may find the integration value of this thing also, and that will be clearly e power x into sin x plus c. Very easy, because if you consider e power x into sin x as z, e power x sin x as z, what will be the derivative value? E power x sin x as z you are considering, right? So after that, you need to apply the formula of product derivative formula. So UV method actually. So e power x constant, sin x, derivative of sin x, that will be cos x, plus sin x fixed, e power x derivative, that will be e power x dx equals to dz. And you can watch that that will be there will be e power x outside, and the inner part will be sin x plus cos x, sin x plus cos x, and that was the given integral actually. So you may write this one as the same thing, e power x into sin x plus cos x dx. You may write it as integration dz, and that will be z plus c, and the z value of z here actually e power x into sin x plus c. So that's our basic procedure of method of substitution. So that was our theory part actually, and in our next video we are going to discuss about some numerical problems of, related to this formula. Okay, so that's it for now. Okay, no problem. That's it for now. So if you like this video, then or it is useful for you, then please like this video, share it with your friends, and please subscribe my channel. Infinity within bracket Kuntal Chatterjee. That's my channel name, and press the notification icon and you will get all the notifications there. Okay, so that's the total part of this video. Hope you are enjoying it, and it is, I hope this will be helpful for you. And start your problems, start your textbook problems, and I'm going to come back with some lots of videos with some numerical problems there. Okay, till then, bye.